Hello students, welcome to the fourth lecture of the chapter Fourier Transform. In this lecture, we are going to see self-reciprocal function under Fourier Transform. So before going to the problem, first let us see what is a self-reciprocal function means. A function f of x will be self-reciprocal under Fourier Transform if the image will be preserved. That is, when you take the Fourier Transform of an input, the same input will come as the output, of course, in terms of s, because the time function will be transformed to frequency domain function under Fourier Transform. So if the same function again comes back as the answer, this particular function f of x will be called self-reciprocal function under Fourier Transform. Now let us go to an example problem. Evaluate the Fourier transform of e power minus a squared x squared and hence analyze whether e power minus x squared by 2 is self-reciprocal under Fourier transform. Now this is the problem. So there are two parts here. One is we need to evaluate the Fourier transform of this function, and then we need to analyze using the final answer we obtain here. We need to analyze whether this is a self-reciprocal function. So first let us start the problem by evaluating Fourier transform of this. So as usual, this is the Fourier transform definition. Let us write that. Fourier transform of a function f of x is 1 by root 2 pi minus infinity to infinity f of x e power isx dx. And now we need the Fourier transform of this function e power minus a squared x squared. So Fourier transform of e power minus a squared x squared will be 1 by root 2 pi minus infinity to infinity. Now in the place of f of x, what is the function f of x now? E power minus a squared x squared. So that is what we have to substitute in the formula. In the place of f of x, now I need Fourier transform of this particular function. So f of x is here e power minus a squared x squared into e power isx dx. This e power isx will be a fixed function. Now we have two exponentials here, and so we can club the power. See, e power, this can be written as e power minus, taking minus out common, a squared x squared minus isx. A squared x squared minus isx. Now we are going to use a small mathematical tool here. That is, you are all very familiar about this formula. A minus b equal to a minus b square is a squared minus 2ab plus b square. So this small concept only we are going to use here. See, if you look at this term, this is a squared minus 2ab. So this will be 2ab term. So a squared minus 2ab. After that we need b squared. We need plus b squared. So what is going to be b squared here? So if you look at, if this is a squared, a will be ax. So that's what we have written here. A will be ax. So if a is ax, here one a will be there. This is 2ab. So a is ax. So multiply one ax. Since we have multiplied a, we have to divide 1a to compensate it. So this ax will be a. So this will be 2b. See, this term is 2ab term. This is a squared minus 2ab. So if this is a, what is this? This is 2b. If this is 2b, b will be is by 2a. See, here we have written. So the b term will be is by 2a, because this is 2ab where a is ax, where 2b is is by a. So b will be is by 2a. So we need b squared now. A squared minus 2ab plus b squared. So what is going to be plus b squared? See, this is b. b is is by 2a. So b squared will be I squared s squared by 4a squared. See, if this is b, this is b squared, I squared s squared by 4a squared. See, just like that, simply we cannot add. So to compensate that, we have subtracted the same term. So plus whatever you introduce minus the same term. So it's like adding 0. Now look at this. A squared minus 2ab plus b squared. So this, the first three terms together, it will become a minus b the whole squared formula. So that's what we have written here. A minus b whole squared. So if you look at this is a squared minus 2ab plus b squared. These first three terms can be written as a minus b the whole squared into what will be remaining then apart from the first three, e power minus minus. So this term will be remaining, that is e power minus into minus. See, this minus into minus will become plus. So it is e power I squared s squared by 4a squared. So e power I squared s squared by 4a squared is this, because I squared is minus 1. So this is how we get in the next stage. Now when you look at this, e power minus ax minus is by 2a the whole square. So we have to make a small substitution here. Put this term as t, that is ax minus is by 2a. Let us make a substitution as t. So when we make a variable substitution, dt will become a into dx, but the limits will be the same, because when x is minus infinity to infinity, t also will be minus infinity to infinity. Now make this substitution here. So now the Fourier transform becomes 1 by root 2 pi. See, this e power minus s squared by 4a squared is independent of x. So this is not connected anyway to the integration. So this term can be taken out of the integration like this. So this term can be taken out of the integration. Now minus infinity to infinity, e power minus, see this totally we had made as t. So now this is simply becoming e power minus t square. This is t. So this is e power minus t square. This has come out dx. What is dx? See here, dt is a dx. So dx will be dt by a. dx will be dt by a. So we get like this. In the next stage, if you look at this, there is a famous integration formula. Should remember this formula for this problem. Integral minus infinity to infinity e power minus t square dt will be root pi. So this basic integration formula, you have to make use of this formula here. So in the place of this integration, now you can write root pi. And of course this 1 by a is a constant which we can take out of the integration. So this term becomes now, that is Fourier transform of e power minus a squared x squared, which we are finding, becomes outside already we have e power minus a squared, s squared by 4a squared by root 2 pi. And this 1 by a has come out here into this integration. According to the formula, as per this formula, this integration has become root pi. So we have substituted the formula and the final answer is this. Cancelling root pi and root pi, we have the final answer of Fourier transform of e power minus a squared x squared as e power minus s squared by 4a squared divided by a into root 2. So this is the Fourier transform answer. Now from here, another part is there in the problem. We need to analyze whether e power minus x squared by 2. We need to analyze e power minus x squared by 2. So that is the question. Here you can see e power minus x squared by 2. We have to analyze whether it's a self-reciprocal function. So from this answer, see, from this answer, how we shall get e power minus x squared by 2? From here, I need e power minus x squared by 2. So what shall I substitute for a squared? Can't we just substitute a squared as half? So if we substitute a squared as half, this becomes e power minus x squared by 2. So let us substitute a squared as half. It means a is 1 by root 2. So when you put a squared as half here, this left side becomes f of e power minus x squared by 2, because a squared I am making as half. So this becomes a squared, when you substitute half, f of e power minus x squared by 2. And similarly, what happens to the right hand side? A squared is half here. So this becomes, if this a squared is half, this is e power minus s squared by 2. And in the denominator, a squared is half. So a is actually 1 by root 2. So if a is 1 by root 2, this is root 2 into 1 by root 2. Substituting a as 1 by root 2. So you have like this. And this root 2 and 1 by root 2 will be cancelled. And finally, f of e power minus x squared by 2 we get as e power minus s squared by 2. Now when you observe this, this is the most important part we have arrived. when you observe this, see, look at, for the function e power minus x squared by 2, when we take Fourier transform, the final answer we receive as e power minus s squared by 2. So the same function is repeated in the answer. So the input, the same image of the input is coming as the output. So that is why this particular function is called self-reciprocal under the Fourier transform operator. So this is self-reciprocal under Fourier transform. And using this concept, try these problems. Evaluate Fourier transform of e power minus x squared and analyze whether it is self-reciprocal. Similarly, next, find Fourier transform of e power minus x. Thank you.